Hello, Assalamu alaikum. Today we will learn how to make automatic power factor improvement of induction motor system in MATLAB Simulink. So in this project, we will make this system's simulation. So I have already made this system. So I will double click on this simulation, then it will open. Now uh, this is the system. Now we will understand from beginning to the last that first this is here we have a source, and then we have a induction motor, asynchronous machine, and then these three are we have a capacitor banks, and these are the circuit breakers, and these are displays which we will show the status of circuit breaker, whether the circuit breaker is on or off. And this is an Arduino function block, and this is gain, and these are the displays which will show power factor value and motor speed and RPM. And this scope will plot a graph between uh, time with speed of the motor and torque, and this constant block will give the torque or load to this induction motor, and these combination of blocks will calculate the power factor. So we will understand how the power factor will calculate in this simulation. So first we will connect a voltmeter. This is a voltage measurement. So and the second one is a current measurement. So when how much the current is drawn by the induction motor, and the voltage on the terminal of the induction motor will be get from these two sensors. These are the ammeter and this is the voltmeter sensor. So this will senses the voltage and current respectively, and then this will get the signal to the power block. So this power block, this is a this is made by the MATLAB, and in this block we will give it a voltage and a current signal. So it will calculate automatically power, active power and reactive power. So from that we will calculate the power factor. So you will have a power factor formula for that. Cos theta is equal to active power upon reactive power. So for that we will make formula from using these mathematical blocks. So in this first we will multiply this active power, and we will make it a square, and then the reactive power make it square. So then after the making both of squares, then we will add both, and then we will take a square root. Then the answer will be a, apparent power. So now in this here it will give apparent power, and then we will get active power. So in the formula cos theta or cos phi is equal to active power upon apparent power. So for that the cos and the active power will be divided by the apparent power, and then it will give a cos theta, which is basically a power factor. So it will show in this LCD. Now we will understand the this functional block, and this again why we connect this gain. So first I will explain that the power factor it will give us in the points form, because power factor is always less than 1. So in the function block, so we will make a function which will automatically trigger the values of the circuit breakers. It will become on or off. It will be automatically on or off. And in the series, this circuit breaker is connected with this capacitor. So when circuit breaker becomes closed, then this capacitor bank will be connected in parallel with the terminals of induction motor. So hence the power factor of the induction motor will be improved by connecting this capacitor bank with the uh, induction motor, asynchronous machine. So we have here three capacitor banks. One is the capacitor 1, capacitor 2 and capacitor 3. And this is the induction motor, and this is the uh, constant block from which we will give the load. Basically, load is a form of torque, and torque's unit is Newton meter. So we will give a Newton meter as a torque. And now we will understand why we connect this series RLC branch, because the capacitors are not connect in the simulation directly with the induction motor. So for that we must connect a series RLC branch. So for that we connect this RLC series RLC branch. So now we will see this display how calculate the RPM. And now this is the induction motor, and inductor in the MATLAB simulation, induction motor gives us speed in radian per second. Radian per second is a unit of this angular speed. So for that we have to understand in speed in the RPM, round revolution per minute, round per minute. So for that we have to calculate radian per second into RPM. So for that we connect this gain, and this is the 30 by pi. We when double click on it, it will show the value which is into in this block, in this gain block. So it will convert the radian per second into round per minute, revolution per minute, round per. And now we will understand why we connect this gain. So this gain is basically a value. I set value of this gain by 10,000, because the power factor values are always in less than 1. And here the 10,000 gain is multiplied with the power factor value, and it will convert it in a whole integer. So we will easily use the whole integer values in the program after. So for that I connect this gain. So and now we will understand the now we will see the values of each block in this simulation. What values we have put in the capacitor, or voltage source, or is the induction motor, the capacitor start induction motor, and other in the circuit breakers etc. So we will start from the voltage source. When double click on this voltage source, we will show the values what we input it to this block. Here, the peak value, peak amplitude is in volt 311.1. It is in the Pakistan or India, we are using 220 volt. So we will convert this 220 volt in peak, because a 220 volt is basically a MRS value. So we will convert it into peak value. So we will multiply it with the square root 2. Then it will give value of 311. So that's why I give it 311, because it get value in the amplitude peak value. And this is the phase degree. Phase is 0 and frequency is 50 hertz in Pakistan or India. So and the remaining is none. Then click OK. Now we will understand the value of this resistor. It is, I set it to, and now we will see this circuit breaker. Now this is the circuit breaker. It has initial status is 0. It means in the initial this circuit breaker is open. Open means its terminals are not closed, and the remaining the breaker resistance and snooper resistance and snooper capacitance, I set these all values as 0. And also this circuit breaker, and also this circuit breaker. Now we will understand the values of this capacitor start series synchronous machine. Double click on it, then it will give the mechanical input is a torque. It is basically a load which we will give to the induction motor on the induction motor's axle, and the units are SI units, and this is the capacitor start. And now we will see the parameters. I have set these values as 311, 50 is the frequency, and 311 is the peak voltage, and frequency is 50 hertz, and the power of the motor is 0.5 horsepower. And because 1 horsepower is 760 watt, so that's why 760 is multiplied with 0.5. So, and the remaining values are like this. Then click OK. Then we will see the this these values. This is the product, and this is the addition, and this is the square root, and these are the divide block. Now, and this is the power GUI block. Now we will understand why we use this power GUI block. Because in the simulation, in the electrical, when we will design an electrical system, then we will require a power GUI, and these all components are uh, imported from the library browser. When you click on this, then it will open this library browser. Then you will go to the Simscape, and then go to the electrical, and then go to the uh, specialized power system. Then you will have this power GUI, and power GUI block is will be used with these all components in the control electrical machine and these other components. So here from here you will import these all components, or you simply single click on it on this and write any name of the block. For example, I want to import a gain block, then just write it a GAIN, then it will show here. Then when you click on it, then it will import this element to this simulation window. So now we will cancel it. Now we will understand the program of this project, but we make the program which will make basically automation in this simulation in the power factor improvement. And after it we will see the working of how the power factor is improved. So now we will understand the program of what program we write in this Arduino functional block. Here Arduino, or I am using Arduino as a controller which will control the signal, which will read the signal of the power factor, and then it will on or close give the signal to the circuit breaker, and automatically connect this capacitor banks with the terminals of the induction motor to improve the power factor. So double click on this function block, then it will leads to the program, what function, what program we write. And here we will understand from the beginning that the function is made as a Arduino Uno, and here three are the outputs. One is the CB1, and CB stands for the circuit breaker, and circuit breaker 2 and circuit breaker 3, and there is the power factor value. PF is the power factor value, and here we getting one as an input, and input is a power factor. So what we will have a input, then it will be defined in these brackets after the name of the function. So then we will comment out some messages. One is the name of the project, automatic power factor improvement of single phase induction motor. And then my name is Samandar Afridi. I am 19 electrical from Qaid Awam University of Engineering Science and Technology, Nawabshah. And today date is 06/06/2023. And then there is the main program, what perform the function. So now we will understand from the beginning. There is I have put if else conditions. So in the first condition, if is it will read the value of the power factor. If the power factor value is between 4999 to 5002, basically this is the in the points form. So in the simulation we multiply the power factor value with 10,000. So after 10,000 multiplying, then it will give the value in the complete integer form. So it will becomes easy for us to use these values in the function in the program. So now after these instructions, the next instructions will be performed as circuit breaker 1 is now the status of the circuit breaker 1 is 1, and circuit breaker is 0, 2 is 0, 3 is 0. Now we'll understand how these instructions will be performed. First, we will understand how the power factor value is on the load on the load, and the load I am using here is 3 Newton meter, 3 Newton meter, 3 Newton meter, and 4 Newton meter, and 5 Newton meter, and I will get the results on only three values, and these three values are 3 Newton meter, 4 Newton meter, and 5 Newton meter. So here now we will understand again program, and in the next condition, the if the power factor value is between 5866 and 5862, then the circuit breaker 1 and 2 both will becomes closed, and both capacitor banks will be connected, and the power factor will be improved. So these condition, basically in the first condition we are applying only 3 Newton meter load, and the second condition we are applying 4 Newton meter load. So as we are increasing load on the induction motor, then it will drop the uh, power factor value, and here is the power factor value is dropping, then we will connect automatically with the capacitor banks to improve the desired value and to get the desired value of the power factor. So in the third condition we are applying load as a 5 Newton meter, and in this uh, condition the all three capacitor banks will be connected, or these capacitor banks will be in action to improve the power factor, and the else condition will become a, and this condition the all circuit breakers will become off. So this is very simple a program. So now we will understand the working. So now we will go to the again the simulation, and now we will first we will check what is the power factor of the induction motor if we not connect any capacitor bank. So first I am comment outing these circuit breakers with capacitors. Now I commented out the circuit breakers. Now I will run this simulation to check the value of power factor before connecting capacitor banks with the induction motor. So it will give us some warnings or some errors. So we will check it. Now we will again run this. Now we will see what the error it is giving to us. The current directory is not reserved for the MATLAB files, because in the initial I make this simulation in the out path of this simulation. So for that I will again uh, paste again changing the path of this simulation file. So I will make the simulation file, and I am copying cut it, and I am pasting it out of the uh, file of the where we install the MATLAB. So we will paste here this simulation file in the place of where we not install the MATLAB file, or out of the MATLAB installation file. So this I install the MATLAB file here in this path. So I am pasting this here. So now I will run the simulation, then it will give no error. So again I am going to here, and then I will run this simulation. Now it is giving a fail to evaluate mask initialization commands. Now again I am running it. Now you will see that it gives no any error in the simulation. So here first we will understand what the value it is giving to us. And the first, it is giving us value of 0.522 as a power factor value. And here we are not connecting any capacitor with the induction motor. So now I am commenting this circuit breaker and applying 3 Newton meter as a load, and then I will we will see the uh, function performance of this simulation. So now run the simulation. Now you will see here you will analyze that the first circuit breaker status is now on. It means 1. 1 means the circuit breaker is now closed. It means this capacitor bank is connected with the induction motor. When we apply 3 Newton meter before connecting this capacitor bank with the induction motor, it was gives value of 0.52 as a power factor value. And now this capacitor bank is connected with the induction motor, and it is giving us improved power factor as 0.9389 as a power factor. So if we are increasing the load on the induction motor, as now I am giving it a 4 as a 4 Newton meter as a load, then click OK. Now run the simulation. Now you will see the power factor. It is understandable that when we apply the load on the induction motor, it will drop the power factor. So when I apply the 4 as a load on the induction motor, then it will drop the power factor, and thus function block will automatically senses that the power factor is dropped, and it will automatically on this capacitor bank uh, with the with the capacitor start induction motor and improve the power factor. Now it improved to 0.9744. And if I am increasing the power factor with 5, then okay. Now you will see the power factor will be improved. It is now 0.9878. Now one thing is remaining, that is what is the capacitor values in these capacitor banks. So I will double click on it and will show the value of the capacitor. Here I am using 70 microfarad capacitor, and this one is also this one is a 40 microfarad capacitor, and this is a 65 microfarad capacitor. You can also change according to your motors performance and motors ratings. And I will give this simulation file in my GitHub, and the link will be I will give the link in the description. You can also go the link and download it. And I hope you understand this project very clearly. If you get this video helpful, then like it, share it, and subscribe to my channel. Thank you.